Hello everyone, I'm Pavithra Naik. I'm studying in B.Ed at KLE College of Education, Ankulam. In this video, I'm going to talk about very interesting chapter motion. It includes motion, uniform and non-uniform motion, speed with the direction, rate of change of velocity, graphical representation of motion, and last one, uniform circular motion. So, what is motion? A movement of any object from one position to another position with respect to the observer is called as a motion. There is a difference in way we use the word motion in day-to-day life and way we use it is in science, right? So, make it point clear. Let us understand the few examples for motion. In everyday life, we see some object in at rest and other in a motion. Birds fly, fish swim, car move, atoms, molecular, planets, stars and galaxy are all in motion. We often to perceive an object to be in a motion when its position changes with the time. The motion of earth changes the phenomena of sunrise and sunset, changing the season. Let us go for the next concept, uniform and non-uniform motion. Uniform motion, a body is said to be in uniform motion if it is travel equal distance in equal interval of time. Non-uniform motion, a body is said to have non-uniform motion if it is travel unequal distance in equal interval of time. Let us consider an object moving along a straight line. Let it travel 5 meter in the first second, 5 meter more in the next second, 5 meter in the third second, 5 meter in the fourth second. In this case, the object cover 5 meter in each second. As the object cover equal distance in equal interval of time, it is said to be in uniform motion. The time interval in this motion should be small. In our day-to-day life, we come across motion where object covers unequal distance in equal interval of time. For example, when a car is moving on a crowded street or a person is jogging in a park, these are some instance of non-uniform motion. Let us go for the next concept, speed with the direction. Speed with the direction is called velocity. Velocity is the vector that includes a speed and a direction. The velocity of an object is the rate of change of its position with respect to the frame of reference. And it is a function of time. Velocity is the physical vector quantity. It has both magnitude and direction. Let in case the velocity of an object is changing at the uniform rate, then average velocity is given by the arithmetic mean of the initial velocity and final velocity for a given period of time, that is average velocity is equal to initial velocity plus final velocity divided by 2. Mathematically, VAV is equal to U plus V divided by 2, where VAV is the average velocity, U is the initial velocity and V is the final velocity of the object, and speed and velocity have some unit, that is meter per second. It is mathematically denoted by m bar s. Let us go for the next concept, rate of change of velocity. Acceleration is defined as the rate of change of velocity. Usually, acceleration means the speed of changing, but not always. When an object moves in a circular path at the constant speed, it is still accelerating because the direction of its velocity is changing. Then which is measure of the change in the velocity of the object per unit time, that is acceleration is equal to change in a velocity divided by time taken. If the velocity of an object changes in from an initial value u to final value v in the time t, the acceleration a is equal to v minus u divided by t. This kind of motion is known as acceleration motion. The acceleration is taken to be positive if it is the direction of velocity and negative when it is opposite to the direction of velocity. The SI unit of acceleration is meter per second square. It is mathematically denoted by ms raised to minus 2. us go for the next concept, graphical representation of motion. We use the line graph to describe the motion of an object. This graph shows the dependency of a physical quantity, speed or a distance on another quantity, for example time. Graphs provided a convenient method to present the basic information about the variety of event. For example, in the latest of a one-day cricket match, vertical bar graphs show the run rate of team each over. As you studied in a mathematically straight line, graph helps to solving the linear equation having two variables, that is distance time graph and velocity time graph. And the first one is distance time graph. If an object moves along in a straight line, the distance traveled can be represented by the distance time graph. When you know that the object travel equal distance in equal interval of time, it moves with a uniform speed. This shows that the distance traveled by the object directly proportional to the time taken. This for a uniform speed, a graph distance travel against the time is a straight line. Next go for the velocity time graph. Velocity is a time graph are used to describe the motion of the object which are moving in a straight line. They can be used to show acceleration and to work out displacement physics. You know that the product of velocity and time give displacement of an object moving with a uniform velocity. The area enclosed by the velocity time graph and the time axis will be equal to the magnitude of the displacement. Let us go for the next concept, equation of motion by graphical method. When an object moves along in a straight line with a uniform acceleration, it is possible to relate its velocity, acceleration during motion, and its distance covered by it is certain time interval by the set of equation known as equation of motion. There are three such equations. These are v is equal to u plus at, s is equal to ut plus half at square, 2as is equal to v square minus u square, where u is the initial velocity of the object which moves with a uniform acceleration for time t. V is equal to final velocity and s is the distance travelled by the object in a time t. Let us go for the equation for velocity time relation derivation. Consider the velocity time graph of an object that moves under the uniform acceleration as shown in a figure. From this graph, you can see that the initial velocity of the object is u and then it is increasing to v. In time t, the velocity change at a uniform rate a in a figure. The perpendicular line BC and BE draw from a point P on the time and velocity axis respectively, so that the initial velocity is represented by OA. The final velocity is represented by BC and the time interval T is represented by OC. BD is equal to BC minus CD represented the change in a velocity time interval T. Let us draw AD parallel to OC. From the graph we observe that BC is equal to BD plus CD is equal to BD plus OA. Substituting BC is equal to V and OA is equal to U. We get V is equal to BD plus U or BD is equal to V minus U. From the velocity time graph, the acceleration of the object is given by A is equal to change in velocity divided by time taken is equal to BD by AD is equal to BD by OC. Substituting OC is equal to T and we get A is equal to BD by T. BD is equal to AT. By using equation and we get V is equal to U plus AT. Let us go for the next concept and last concept, uniform circular motion. When an object moves on a circular path with a constant or uniform speed, it is said to have a uniform circular motion. For example, motion of the hands of a clock, motion of the moon revolving around the earth. When its object is in a circular motion, direction of its velocity keep on changing. When a radius is r, velocity is v is given by v is equal to 2r by t. When an object moves in a circular path with a uniform speed, its motion is called as uniform circular motion. So today class we will study about the motion. And thank you.